Hi everyone. In this video, we're going to look at an activity covering an introduction to ggplot2. So this activity, the materials for this activity were developed based on a slide set created by Dr. Lucy D'Agostino McGowan, a professor in statistics and data science at Wake Forest University. So her slides were really helpful, so that's what this activity is was created based on. So in this activity, we're going to be looking at the code, how the code is structured for ggplot objects, how ggplot plots are made up of what we call layers, how we can modify the labels and captions of ggplot objects, how we can customize aesthetics of ggplot objects, and how we can use those to show additional dimensions or variables in a data set. And then we'll also talk about the difference between mapping of aesthetics versus manually setting of aesthetics. So we'll start off the activity by opening up RStudio and opening a blank R Markdown document. Any of the three major file formats, Word, PDF, or HTML, should work for this activity, but I think HTML would work the best here. Okay, so we're going to go File, New File, R Markdown, HTML, and sure, let's call it Introduction to ggplot2. Okay. All right. And below the setup chunk, everything that's in the template document, we can get rid of that to start. Okay. And then we can just knit this document. Let's call it Intro to ggplot. All right. So we get this blank HTML document, nothing in it yet. We're going to fill this up with the activity as we go here. Okay. So before we go ahead and get started with the activity, one thing I want to point out is that when you are knitting to an HTML document, okay, the default style of the document is fairly plain, which is fine. But optionally, you can sort of give this some extra flair or make it a little bit fancier, just style-wise, which is entirely optional, so you don't have to do this. But there's this nice package called Pretty Docs. So if you Google this, Pretty Doc, okay. There's some nice code for modifying your HTML output when using R Markdown. Okay. So you have to be careful with the spacing in here in the YAML. This section of the R Markdown document is called the YAML again, YAML. So I would always copy and paste it from here. And then you may need to install the Pretty Doc package if you don't already have it installed. So install that packages, Pretty Doc. You'll need to run that in the console. Yeah. Potentially. Okay. And then you should be able to do this. So for example, here's the K-Man theme, which is one of the themes available from this Pretty Doc package. Okay. And if you knit it now, you'll see the HTML output is styled a little bit different. So it's just a little fun to sort of give a little extra flair to your R Markdown output. But entirely optional. Again, you don't have to do this, but it's pretty nice. So I'm going to stick with the I really like the architect theme, so I'm going to use that here, okay, as we go through this activity. And as a reminder, this only works if you're knitting to HTML. It does not work for the other, for PDF or Word output, but it's kind of a fun thing to style your document, a little bit different if you're knitting to HTML. Okay. All right. So going ahead and getting started on the activity. So first thing we're going to do, as we do with most activities, is load the necessary packages. So we're going to copy this and insert a new chunk, and then knit this document. Now you should see that this has some extra warning messages in here that happen when we load the tidyverse package. So typically you wouldn't want this extra output showing up. You really only want the code and the plots or tables that you create. You typically don't want these extra messages showing up in your R Markdown output like this. It's good to see when you're coding inside the R Markdown document. It's like a message in here, but not in your final document. So we're going to suppress that by adding or setting a global chunk option here in the setup chunk by setting the message option to always being false and the warning option to always being equal to false. Okay. And now you'll see if we knit the document again, the code is still there. It's still being executed. It's still loading these packages, but those warnings and messages are now suppressed. So it's a little cleaner looking. Right. Additionally, since we typically want this to compile, even if there's errors, we can add that error equals true option as well. We don't have any errors yet in any of our code, so this won't change anything, but this global chunk option here sets all of the chunk options for all of the code chunks that we'll create here moving forward. Okay. All right. So talking about ggplot2, the R package from a high level. So ggplot2 is one of the most popular R packages for data visualization among R programmers today. So historically, there's been other packages for data visualization, like Lattice is another very popular one that's not a part of the tidyverse that came before ggplot2, I believe. Base R graphics are also an alternative for data visualization. So we won't be using that in this course, but just to show some of the common base R functions. For example, you can create a scatter plot using the plot function. And again, these are functions that we are not going to use in this course, but just to show you the options out there. So this creates a basic scatter plot here. You can also have a histogram, make a histogram of 50 random values from a normal distribution here. Okay. You could also have a box plot. Okay. So these functions from base R, so they're available in R without loading any additional packages. That's what I mean when we say base R. There's functions that exist for data visualization already, but they're somewhat limited in terms of how you can customize them and how easy it is to add additional variables to the plot to make them more complicated in a way. So they're great for a quick look at the data, maybe. But if you want to make more advanced data visualizations, show many variables at once, use colors and shapes effectively, ggplot's the way to go. Okay, so that's what we're going to be covering in this activity. So ggplot2, the package, was created by Hadley Wickham, who is chief data scientist at RStudio. And it's one of the many packages that now make up a collection of R packages called the tidyverse. And these packages are maintained by developers at RStudio and lots of people who just contribute to these open source packages. So all these packages, as a reminder, constitute the tidyverse, and each has their own sort of specific role. readr is useful for importing and exporting data sets. Forcats, for example, is useful for working with factor type variables in R. Lubridate is useful for working with date time variables in R. Okay, so we're looking at ggplot, which is all about creating effective data visualizations. So the general structure of a ggplot object that you make with ggplot2 is this format here. So you use the ggplot function, and the first argument, the data argument, you provide is the data set, the data frame, or the tibble, the tidy table. Then you also supply a mapping argument, which you give via the aesthetics function. So AES is for aesthetics, in which you commonly, but not always, supply a x-axis variable and a y-axis variable here. And lastly, this ggplot portion of the code creates a blank canvas, a blank rectangle for which a plot is going to be drawn on. And then this geom part of the code here is adding the plot. So for example, if we wanted to make a histogram, this would be geom histogram. And if we wanted to add or construct a box plot, we would use geom box plot in place of this. So this framework, in which we have plus signs at the end of these lines here, is showcasing what Hadley calls the grammar of graphics, which is what the GG stands for in ggplot, grammar of graphics plot. So Hadley views, rather than how base R creates a single plot in one function call, for example, where the entire thing is built in one single function, Hadley Wickham, when he created this style for creating data visualizations, he viewed it as you should be constructing this plot step by step or layer by layer, starting with this blank canvas, adding one layer and potentially adding other layers to it. So let's see how this works throughout this activity here. So we're going to jump right into a data set and practice making data visualizations with ggplot. Okay. So we're going to be working with the Palmer penguins data set in this activity. So this is a real-life data set collected on penguins from the Palmer Archipelago Islands in Antarctica. Okay, so I linked here to showcase where that's at, Google Maps here. So this is way, way, way south of us here, way below South America. That's where these archipelago islands are at, that this data was collected on these penguins. Okay, so there's a bunch of penguins down there. This research team collected data on chinstrap, gentoo, and adelie penguins. and measured their bill lengths, their bill depths in millimeters, their flipper lengths, their body mass, okay, all kinds of characteristics they measured about all these different penguins. Okay. So the first thing we're going to do is we're going to import this data, load it into R using the data function here. So this is a unique way we can load data when it's made available via an R package. So the Palmer Penguins package has its sole purpose being to make this data set available, this penguins data set. So that's how we're using it here. So we're going to copy it along with this glimpse code, paste that into R, and knit this and see. Glimpse will give us a good first peek at the data set here. Okay. So from the glimpse output, which is always a good place to start when getting acquainted with the data set, we can see there are 344 observations or rows of the data set and 8 columns or variables. So it shows us the different variables, their names here, and then it also shows us the types of the variables here. And then it prints the first few values for each of the variables. Okay, so these are all Adelie penguins for the first few measurements. This species variable is a factor variable. So FCT is for factor here. That's similar to a string or character variable, but when you have repeated strings that will show up. So for example, many penguins were Adelie. Many were Gentoo, and many were chinstrap penguins. So because that repeatedly shows up and it's like a string or character, R encodes that as what's called a factor variable. Similarly with the island variable, there was 3 different islands that the penguins were from. So that's coded as a factor as well. DBL stands for double. So this is a double type variable, which you can think of as just a continuous numeric variable or quantitative variable. R differentiates between double and integer variables. But as far as we're concerned, we can treat them the same. It's just R can be a little bit more efficient with memory when it stores something as an integer, if possible, rather than a double, which takes up more memory. But again, for our concerns, we don't care as long as it's numeric one way or the other. So that gives us a little bit of a glimpse into the penguins data set. Okay, so now for the next good portion of the activity, we're going to be looking at building this plot, this ggplot here, layer by layer, piece by piece. So we're going to build our way up to this. But this is the final product that we're working towards here. So this is a scatter plot showing the relationship between bill length and the bill depth of the penguins. So first thing we're going to do is we're going to draw our blank canvas. So we're going to copy this code and show how Hadley visualizes the data visualization process. He starts with this blank rectangle. So first, we will start with a blank canvas. And if we knit that, all right. So we can see here our blank gray box that we've created. So not much going on yet. All right. But now we'll add our first variable. So we'll add an x variable. We're going to copy that code. So next, let's add an x-axis variable. Okay. So we'll knit this. All right. And so we're going to be creating a new code chunk for each edition, just to show the process of building this ggplot layer by layer, okay, just to make that very explicit. So here we can see we added the one variable, but still nothing's showing up yet. We haven't told it if it's a scatter plot, if it's a box plot, if it's a histogram. We haven't told ggplot anything about that yet. So it just has this blank canvas still. Okay. Then we will add a y-axis variable. So we're going to add the bill length. So we'll copy this code. Okay. And we will knit that. Okay, and now we see before we got the vertical lines, now we have this cross section of vertical and horizontal lines of the two variables. Okay. So again, building this ggplot from the ground up. Okay, so now the biggest step that gets us much closer to the plot we're working towards, we're going to add points onto the plot, draw points onto the plot. So we can do that using a geom point layer. So let's copy this code. Finally, we can add points to our plot using geom points. Okay. So if we knit that, all right. So now we can see each of these points, which represents a two-dimensional observation. It has the bill depth of the penguin and the bill length of the penguin. So this penguin, for example, had a bill depth of about 17 millimeters and a bill length of, looks like about 59 millimeters. And there's all these 344 dots, each one a penguin. So that's the fundamentals of ggplot. But we can customize this with lots of different aspects using what are called aesthetics. Okay. So aesthetics in data visualizations can be used to differentiate between subgroups or to show additional dimensions or variables in the data set. So we're only showing two variables in the scatter plot up here, for example, but we could use color to represent the species of the penguin. We could use color to represent the island that the penguin came from. Color is sort of the first one that comes to mind, but we could also use the shape of the points here. So triangles could be for Gen 2 penguins, maybe square points for Adelie penguins, and circles for chinstrap penguins. So color is typically preferable because it's easier to distinguish subgroups from one another quickly as compared to shapes, but shapes are nice too because they're agnostic to the color aspect of the plot. So for example, if color blindness, if you want to be friendly for those with color blindness, using shapes is one way to alleviate that issue, make your plot more accessible. Okay. You can also use the size of the points to show additional information. So we could have, for example, if we wanted to also convey the flipper lengths of the penguins, we could have points in this plot be larger as the penguin's flipper length is larger and smaller as their flipper lengths are smaller. And that would add an additional variable to this plot, or additional dimension. Lastly, these are some of the more common aesthetics, but there's many others, too many to list here. Lastly, one of the last more commonly used aesthetics, although this is the least common of these four, is the alpha aesthetic, which controls how transparent the points are. So you could make them more see-through or transparent if a value is lower of an additional variable, and then maybe the ink for the point is darker, more visible if it is a higher value for a third additional variable here. So these are all additional ways in which we can customize data visualizations in ggplot2. So this again is the benefit of ggplot, and that just about anything you can imagine you want to customize in this plot, you can do that. Whereas base R, there's less options. So you want to remove these grid lines and just have it be a solid square, you can do that. If you want the background to be entirely white behind the points, you can do that. If you want the points to be square and green in color, you can do that. So the point being, it's very customizable. So we have some added complexity in the code, but it allows us much more options for customizing our data visualization when we use ggplot. All right, so looking at some other aesthetics, again, we mentioned how you can use shapes to differentiate between points. You can also use colors. This graphic's showing how the efficiency in decoding groups is lower to the left side of this and then higher to the right. So in other words, we can differentiate between color much more quickly than we can differentiate between shapes when looking at a plot. So generally, you would want to use color rather than shapes if possible, while keeping colorblind friendliness in mind when you do that. You can choose colors that are colorblind friendly. And also we can use aesthetics like not just for when we have points on a plot, sometimes you have like a line chart or other types of plots with lines. And so you can color the lines, of course, as well to differentiate between different groups. And rather than shapes, you can't really have like a triangle line. You could use different line types. Typically, that's how you can differentiate between groups. Or if you want to show an additional quantitative variable varying by different lines, you could change the line thickness based on a certain quantitative variable. So lots of options for aesthetics to customize in ggplot2. We're going to first look at just adding color to the plot to color the points based on the species of the penguin. Okay, so I don't have code anymore to just copy and paste for this part, but we're going to add it here. Okay. So let's copy the chunk from last time. Now let's color the points based on the species of each penguin. Oops. So we add the color option in the aesthetic function. So we have x equals y equals, and we'll add color equals. And if we look at the penguins data set, we have this species variable. So that's what we want to color the points based on the species of the penguin. So that's how we specify the color aesthetic here. Okay. So now if we do the green triangle, you should be able to see the scatter plot, and it's colored based on the species of the penguin. Okay, and we can also knit the entire document. Okay. So we're getting there. We're getting closer to that original plot. So note that ggplot by default selects these three colors. It's like a bluish, a greenish, and an orange or reddish color. This is one of Hadley's biggest regrets, he says, in creating this package, is that they didn't make the default colors colorblind friendly. So note that these may be easy to distinguish for us, but for some, these are not great colors to showcase the differences in the data. Okay. So whenever possible, you want to choose colors that are colorblind friendly to use in your plot. And we will do that. The final plot has that, a selection, a palette of colors that's colorblind friendly. So next, we will add a labs layer to our plot. We add it with the plus sign to give the plot an overall title and a subtitle here. So we'll copy this code. Okay. So we can knit that. So now we can see the title that we added and the subtitle. Okay. So note that by default, ggplot left aligns the title at the top of the plot. It's not center aligned or right aligned, but again, that is all customizable. There's an option we could specify if you Google it to center the title if you wanted to, or to right align it as well. But we'll just keep it as is, as the default is here. So now we'll also customize the x-axis label and the y-axis label in this plot. So these variable names aren't too bad, but we don't really want underscores typically showing up in our plot. They're just not nice to look at. And we're matching the original plot up here, right? Okay, so this had bill space depth, and then in parentheses millimeters, bill length, in parentheses millimeters. So we're going to replicate those axis labels exactly. Okay. So bill depth and bill length. So to add that, copy this. Next, we add axis labels. So to add axis labels in the labs function, we add an X option and a Y option. Okay. And then in quotes, we specify what those axis labels will be. So appreciative of Hadley that he made these options aptly named. The title option or argument, specify the title, subtitle argument, specify the subtitle, and X and Y for the X and Y axes. So X, we wanted build depth, millimeters, and Y, we wanted bill length, millimeters. Okay. So we can knit this. All right, now we have our nice looking axis labels. So we're getting really close. We've almost reproduced that plot that we were working towards right from the start. Before we get to the color, one main thing here, or one small thing I should say, is that the S in species, maybe we want to capitalize that. That's how it is in this original plot that we're working towards. And so having it lowercase is not too big of a deal, but it is possible that you have like underscores, like it could be the variable, maybe the variable name that specified the color aesthetic. Maybe it was species underscore penguins underscore 72, like something like that that doesn't look the nicest. So maybe we want to update the label for this part of the plot that's called the legend. So that this key over here is called the legend of the plot. So we can update the legend title of the plot. So then we update the legend title of the plot. Okay. So we can do that in this case, because the legend is produced only because we specified the color aesthetic. In this case, modifying the legend title only requires us to add this color argument in the labs function with a capital S here. Typically, changing or updating the legend title is a bit more complicated, but again, just because we only specified one extra aesthetic besides X and Y here, it's a little bit simpler. Okay, not too much to update that. Okay. We can see here now it has that capital S like we wanted. All right. So we're on our way. Okay. So the last thing that we'll do is use a colorblind friendly palette. So since these three colors by default are not colorblind friendly, we will use this scale color viridis D function, which the D stands for discrete because the species variable is a discrete categorical variable. We will add this option to our code. So let's copy this. And then lastly, we use a colorblind friendly palette. We'll copy this. And then we're going to copy this scale color viridis. And then we're adding it as a new layer. So it gets a plus, return that. This is the part that changes the coloring of the plot. So if we knit that, okay. Hey, look at that. Now we have this nice colorblind friendly palette. So everyone can enjoy our plots. Great. So congrats, nice work. You've now created your first ggplot2 object. First data visualization with ggplot2. Oh, okay, wait, we forgot something. I forgot something. We forgot the caption. Okay, so to add the caption, let's see. To add the caption to the plot, that is a option in the labs function. So we'll add that. Let's see where that was supposed to go. Ah, okay, just before we did the coloring. Okay, so we can do it all together in this one. So to add the caption, so lastly, we add a caption and use a colorblind friendly palette. Okay, so to add the caption, it's another argument in labs. So it's caption equals, and then we want it to say this source polymer station. Yep. Okay. So now if we knit this, that will be our replicated ggplot2 object, our data visualization. Okay, there we go. Great. Now we have that caption showing up, and that matches what we were trying to produce here. So great. So you might notice that it looks a little bit different, like the size of things is distorted a little bit. This depends on if you're knitting to HTML or PDF or Word, the dimensions are a little bit slightly different. Okay, but this is the same plot. We've now reproduced it. So nice work. Okay, so some last couple things to talk about. So the difference between mapping and setting of aesthetics. So when we set the color, or when we specified the color of the points to be based on the species of each penguin, that is what we call mapping aesthetics, because we're connecting or mapping together variables in the data set and aesthetics that we want to show up on the plot. So in other words, mapping is when we set the aesthetic based on a variable in the given data set. So for example, here, we could look at how we can set the size aesthetic to be based on body mass and the alpha aesthetic to be based on the flipper length of each penguin. So example of mapping aesthetics. Okay. We can see what that looks like here. So the size of each point shows how large the body mass is for each penguin. So you can see like this penguin was much bigger in body mass than this penguin down here. And the darkness of the point, which is controlled by the alpha parameter. So this is controlled by the size parameter, and this one's controlled by the alpha parameter or aesthetic. So the darkness shows how long the flipper lengths are for each penguin. So we can see these penguins over here had much longer flipper lengths than all the other ones. So typically you would resort to using color instead if you can, but sometimes it's helpful to show additional variables in the data set with these different aesthetics. Okay. So that's mapping aesthetics. So the color, how we used that before, that was an example of mapping an aesthetic. How we set the size and alpha parameters here, that was another example of mapping aesthetics. We can also do what's called setting aesthetics. So manually fixing them, not as functions of the data set. Okay. So we can do that here, where say we want the size of all points to be equal to 2. And we want the transparency of the points to be equal to 0.5 for alpha here. So we can reproduce that plot right here, where all the points are the same alpha and size. So example of setting an aesthetic. And if we knit that, okay, you can see here how they don't vary based on the data. And so no legend was produced either. Okay. Just another way you can customize your plot if you want. So another thing to showcase with this is that you have to be careful where you specify these aesthetics at. if you want to manually set them, if you want it to be fixed and not based on a variable in the data set, you need to do it outside of the aesthetics function, outside of the AES function. Because I'll show you, for example, here, what would happen if you did not. Like, let's say we wanted to set the size of the points to be 2, and we did it inside here instead. Okay, this does not have an error. But it won't give the results that we expect. Or let's look at color, for example. Okay, so let's say we wanted the color of all the points to be this Dodger blue color. We shouldn't set it inside of the aesthetics function, or else this is what will happen. Anytime you try to set an aesthetic inside AES, it's looking for a variable in the data set to be supplied. So in this case, we gave the string Dodger blue. It didn't find that as a variable in the data set. And so it assumes there was it created a new variable, essentially, called color that always had the value Dodger blue. Okay. And then Hadley just used the default first ggplot color. So it didn't color the points blue like we wanted. Okay, so this is kind of hard to find the issue with this because it doesn't give an error. But what needs to happen is if you want to fix the color in that way, it needs to be specified outside of the aesthetics function. Okay. So like this. Now if we do this, all the points are blue like we wanted. So this is how we can set an aesthetic, manually set an aesthetic. It needs to be done outside of the AES function. Okay. So that's kind of a tricky but an important concept. All right. So lastly, here's a few things to mess around with, toggle some different options on your own for the ggplot object. Okay. Note that I ask about setting the size aesthetic in this bullet here, and then I ask you to do it in a different way down here. So you can overwrite the previous way you set the size aesthetic. You don't need to retain both, and that's okay. Yeah. So try these parts on your own, and then that will be it for this activity. Thanks.